Hi there, welcome back. And I'm getting impatient, and I'm sure you are too. I have gone through the rest of this radio and I've replaced exactly, I think it's 2 capacitors. They were pretty buggered, as expected. I've done a lot of testing of resistors. I have not done it as meticulously as I did some of the other stages because I was anxious to see whether I can get this thing working. But I have tested resistors. They're all showing the same tendencies, which is about 10% high. So they are within spec. There's nothing dramatic. There were no open or shorted resistors or capacitors. So I want to try this on now. I want to switch it on, and I'm going to do it now. I've got the antenna in here. One thing I need to explain is this. This thing is FM and AM. It does not have a separate AM antenna input. The AM antenna is actually derived from the FM dipole inputs. So you connect an external antenna if you want here into one of the FMs. The one on the right here is actually the direct link, and that can serves to pick up your AM as well. And of course the dipole is for FM. So I believe, let's see, I believe anti-clockwise is AM. That is off. I've got the dim bulb tester on at the back there. Tested this thing for audio. So the parts of the circuit where major current is drawn have been tested, and they seem to be okay. I'm anxious to see whether we've got something that's working. So I'm going to give it a go. It's drawing 100 milliamps, 80. Can't hear anything yet. 80 milliamps, and I've got a buzz. Ha! I've got something. Yes, okay. That's AM, I think, yeah. Pretty crappy reception, but I do have a lot of limit on there. I'm going to give it one more light bulb. It's now gone up to 220 volts coming in, 110 milliamps. We are getting some action. This is all Canary Islands. Let's try FM. Yeah, we've got FM. Very, very low. Well, this antenna isn't the best one for FM, is it? Let me try and put in the dipole. It's better. Well, it's there. Well, we've got it. It's working. It's not working particularly well. And I wonder if it's, let me give it another light bulb. I wonder if it's the voltage. But I've got 229 volts coming in, so it's almost no limit. It's 120 milliamps. But it's not very sensitive. I'm comparing this to what I've experienced with other radios on this bench. I normally get about 4 or 5 strong FM stations here. This thing's very weak. So it could either be the tubes, that is the ECC85, or the two EF89s, because we know the ABC80 and the EL84 are fine. Or it could be alignment. Could be that someone has messed with the alignment. Back to AM. Okay, but this is progress. Believe it or not, this is progress. We've got FM and we've got AM. Reception is poor. It's actually poor on both. I wonder if it's... I'm going to try that next. I'm going to measure the voltages after the rectifier and see if we've got close to 175 volts. So just tip this on its side. We need 175 volts at the exit or the output from the selenium diode, and 150 after that first resistor. So let me put that on again. Again, there are 3 light bulbs. It's a total of 140 watt bulb in there. So there is some limit. Let's let this, okay, let this go up a bit and see what we've got. We need 175 or close to it here. Oh dear. There's not much limiting that the dim bulb test is doing, because there's only, actually I'm going to bypass the dim bulb. I think it's safe enough. So we should get 175, we've got 156. We should have 100 and, what was it, 150? What does the schematic say? Yeah, 175 and 150. So 150 here. Yeah, we're short 138 and 155. So 20 volts short over here. 12 volts short over there. And so I believe we've got a problem with this selenium diode. So that means that I'm going to have to replace it with a silicon diode. And then I don't know if I need to drop some voltage. What's the easiest way to do that? Well, let me set something up here. Okay guys, definitely don't do this at home. I've just put a 1N4007 in across the selenium diode. Because the voltage drop across here is about 0.6, 0.7 volts, it should just bypass the diode. And then I'm measuring the voltage, the B plus again, just after the selenium or after the diode, and see what we get on here. Now I'm going to put in a bit more limit because I don't know how much voltage drop this was giving us. We need 175 at that end, so let's go for it. That's on. Okay, it should start dropping now. There's quite a bit of limit on there. There's 1 light bulb. And that's more or less where we were. So let me give it another light bulb. Oh yeah. It certainly goes up. It's actually a bit higher. But I need to know what it is without a limit, but I'm afraid to give it too much. Let me give it another light bulb. It's over 200 volts. I'm not sure what current this thing's drawing. The AC coming in is now at 228, just under 230. So I think that's about as high as it'll go. 207 with no limit, with all the light bulbs in. That's pretty high. Let me try with bypass. 212. Okay, I'm not going to leave that there for long. Okay, so we've got a problem with the selenium diode. With the, so I need to put that diode in, but I need to put a resistor in series. And what I need to do is find out which resistor will give me the right drop so that I can get about 175 as the B+. I literally need to take the output from the diode, pass it through a resistor, and then it'll go to where the original diode output was. I might even do this inside the casing. I'll have to think about that. I don't want to put this on the outside. But I mean, I'll leave this there for too long. Just put some more limits on. This is okay. If I had that, I'd be fine. But this selenium diode is definitely dropping a hell of a lot of voltage, and that means it's probably heating up quite a bit. And the reason this is now dropping more than we had before was that when I tested that voltage there, I only had the two output tubes, the preamp and the power amp, and everything else was inactive. I just didn't think that the rest would draw so much current. But it seems to be fine. There's actually, if we look at it here, 175 to 150, that's 25 volts of voltage drop across a 1K. That's 25 milliamps going into the, the preamp and the other tubes, because that's the voltage drop across that 1K resistor, just between the one filter cap and the other one. So 175 on one side, 150 on the other, that's 25 volts. Divide that by 1K, that's 25 milliamps. So it is quite a fair amount of current. And according to the data sheet for the EL84, I believe if we have about 4 volts, the grid negative voltage, 4 volts grid to cathode, with about 175 volts anode voltage, it's actually biased to about 25 milliamps. So this thing's basically double the current draw. And because it's double the current draw, it's pulling that diode harder, and the voltage drop across the diode is now a lot greater than it was before. Okay, I'm going to stop this here and do that change on the diode and see what we get. I'll have to leave the resistor value open or do some testing and see what I decide. I'll get back to you as soon as I've done that. Okay, you know all the warnings you get about don't do this at home. If you do so at your own risk, etc. Well, consider them issued. Do not try this at home. What have I got here? I've got the AC coming in there. About 200 volts, I would assume. I haven't measured it. Goes through a diode. It's doing exactly what the selenium diode was doing. It then goes through a resistor. And I've got a 100 ohm 5 watt resistor here. And then it goes to where it was going in as B+. I've got the measurement here of the actual B+. And I want 175, and I'm going to switch this thing on. And I'm not going to touch or sneeze or anything nearby. All right? Let's hit it. Let it calm down. We've got some buzz, so it's working. And we're below, we're at 179. But I've got just 2 light bulbs, so this is not enough resistance. But let me give it some more. 190. And the final light bulb, 193. Okay, so that's not enough. So I need a bigger resistor. I need about, I'm going to try 200 ohms. See if I've got a Another one of these hundreds around here. Let me just search for that. Okay, I didn't get another 100. I've got a 220 ohm 5 watt resistor there now. And I switch it on, obviously, and see where we go. Now that's pretty close. We want 175. I'm going to bypass the limit, although there is not much more to go. 183. That's pretty damn good. That's pretty good. 183, it's supposed to be 175. Hey, I can live with that. And the voltage, the mains voltage at the moment, instead of 230, is actually 234. So if I put in the limit, it actually brings it down to 230. So we're at 179. That's what I want. I want 220, maybe just a little bit more. And what do I have over there? Now, as I said, be careful. This is 220 volt voltages here. Mains. 159, so it's a little bit high. It's supposed to be 150. So I need to drop just a little bit more, maybe 250 ohms. And this is where my idea comes in. I'm going to try it and show you. Okay, so what have I got here now? Well, I've got the diode, as usual, coming from the AC, goes through the diode, goes into 4 1K resistors in parallel. That gives us 250 ohms. And the result of that goes to where the B plus was. And now we'll see what voltage we've got. You're probably guessing what I'm trying to do here, but let's just check this first. I want 175. Bloody hell, that's nice. Ha. That is perfect. $177. I'm happy with that. So what have we done? We've replaced the selenium diode with a silicon diode, which drops about 0.7 volts. And then 4 1K resistors in parallel, giving us 250 ohms, which is just slightly more than the 220 that I tried before. And we have these 4 are 2 watt resistors in parallel. That should give us about 8 watts of dissipation, which should be more than enough. And the way to determine that is to see what voltage drop we've got across there. So we do this well, let's just first see what voltage we've got now after that resistor. We wanted 150, we got 156. That's good enough for me. So this is going to work. Now I need to just determine what the voltage drop is across here. I don't like doing this. I really don't like doing this. But I just want to see what that voltage drop is. We've got 11 volts dropped across 250 ohms, which means, if we do some math, what power are we dissipating here? I think that's about half a watt, which means we've got more than enough resistor dissipation on there. And now what I want to do is I want to put it inside, put all that, let me switch this off. I want to put all that inside the original diode's case and close it all up, and it'll just look like the original selenium diode. So I'll try that and then show you what I've done. So the first thing to do is to open up the selenium diode, and you do that by bending those flaps over very carefully. Then you take out the different sections, and when you do, you see the innards. and that's when you dismantle that whole thing. Then putting the new one together is very simple. Just solder the diode with the series resistors in parallel, and you've got yourself your diode with the dropping resistors, and that should do the trick. And here we have it back in place with a couple of rivets to replace the ones I drilled out. And I don't know if anybody noticed, but I found a mistake in building this diode up, and if I'd put it in as I had it, we would have had a major catastrophe. In fact, we would have produced something like minus 175 volts, not plus 175 volts. And that would mean that the filter caps would probably have blown up. And the reason is, this thing, I believe, is labeled incorrectly. I had this selenium rectifier, selenium diode casing with the positive towards me on the bench. And of course, I put the diode's anode on there. The logic being that the diode's anode is positive and the diode's cathode is negative. However, that is not what they had on here. This diode was actually reverse, because the AC is coming into the negative, and that should be the anode if you want a positive rectified voltage. And then the positive there that you see at the end is where your B plus was coming out. That would be the cathode, which should be the negative. So I followed the markings, and I was about to put it in and decided to check everything again. And actually I was checking for shorts to the casing, because I want this casing to dissipate any heat the resistors create. And I found that I had it wrong. So I've had to put it in wrong. So it's as per the original. I don't know where the logic comes in here. I might be just creating a real noob mistake, but this is the way it is. The AC goes into the anode, and it comes out rectified half wave on the cathode, which, according to my understanding of it, the labeling on there is wrong. But I've left it as they had it. And I do have the resistors after the diode, as I had before. I just had to flip everything around. I'm going to test this now. I expect to get the same results that I had just before we put this in the case. And this is just to show you can never be too careful. I mean, I've done this so many times. I shouldn't be making stupid mistakes like this. But if you don't make mistakes, it's probably because you're not doing enough work or playing enough with a hobby, because you'll always make these mistakes. I think maybe just some sixth sense or experience just gets you to test it again. I can only say that that's the only excuse I can give for not having blown this thing up. All right, let's try this now. Enough waffle. So what we're interested in is the voltage we're going to get, and I'm putting it on with the 4 limiting resistors on, but there is a limit. Put it on and let it sort itself out first, and then we'll see. Let's see what we're getting as the B plus now. Okay. I want 175. I have limit on, but there's very little limit. It's safe enough to bypass the dim bulb. The mains voltage today is 230 volts. And I have 176, and I wanted 175. And I'm getting there. Which is bloody brilliant. I've got something coming out, but I'm convinced that somebody messed with the alignments. What was that? It's just a bad connection. So we got 176 over there. And what do we have over here? We have 152. Ha! It's supposed to be 150. We've got 152. And I am happy as a pig in mud. So, next step. I thought maybe that electrolytic on the discriminator circuit might be off, but I've actually tested it, and it seems to be okay. So I'm hoping that somebody messed with the alignments, because that will be the easy fix for the low sensitivity. And I think I'm just going to have a look at that a bit closer. And what I'll do is I'm going to leave the alignment for the final video. And because I really do believe that's it, that's all it is. I have to do something before I mess with that alignment. I need to figure out which coils are which. There are two IF transformers here. Each IF transformer has got an AM section and an FM section. But the messing with that is not so serious as long as you sort of put it back where you had it. The problem is the last one. The final stage of the IF transformer for FM is where you null out. You do the nulling out when you tune it in, when you adjust the alignment. And if you mess that up, it's not such a good idea. And I'm not sure which coils are which. I don't know whether the FM and AM are both closer to the edge or closer to the inside. I have to figure it out. It's not that obvious because they sort of overlap here in terms of the layout underneath. I can see these, there's like 6 points or 8 points on there. And they're not sort of AM one side and FM the other. They're not as simple as that. They do cross over. So I need to go and do a bit of research and figure out which is which. Because I don't have a service manual for this. I did find one for the SK25, but that uses an ECH81 and it's totally different. This one actually has a very interesting front end. It uses the ECC85's one triode as an oscillator for the AM, which is very unusual. And if I get to it, I might just describe that in the final video as well. But for now, I'm happy. We've got the voltages right. I'm convinced that this old selenium diode casing is going to be good enough to dissipate the heat from those 4 resistors. This thing's producing just under half a watt on an 8 watts of possibility. There's 8 watts of resistance in there, 4 by 2 watts. Now, that sort of half a watt doesn't seem much, but it does heat up quite a bit because it doesn't really go far, but because it's connected and tightened to the actual old casing, which is aluminum, and it was meant to dissipate heat, I'm convinced it'll be okay. The other thing to realize is that the voltage drop that we're getting on here, whatever that is, to bring it down to 175, is exactly the same voltage drop that the selenium diode was creating. So whatever heat, and that was also creating it in the form of heat. If you have voltage coming in and less voltage going out, you've got a potential difference. You've got voltage drop. That voltage drop, unless it's a light bulb or a tube, it's going to produce heat. That's the only way that voltage gets sort of leaked away. So that selenium diode was producing exactly the same amount of heat when it was new and working and creating the voltages that we wanted as it is now. So I'm not afraid of that thing overheating. I did rivet it to the case. So besides the actual casing, it's actually riveted to the chassis. So I think we shouldn't have a problem. I will measure it at some point just to make sure, but I'm actually more interested in getting the sensitivity up. But that's it for now, guys. I'm going to look at this carefully and come back with a final video with the chassis and the alignment and the final testing. I hope these aren't famous last words. I really hope that that's all there is to it. There's quite a bit of work to do on removing that paint from the chassis, but I've realized it's not that difficult. But anyway, enough for now. I hope you've enjoyed that. And if you have, please like, subscribe, share, and if you want to support the channel, you can do so on Patreon. Thanks for watching. Bye for now.